All right, folks, we can get started with our lecture today as part of our lecture series. I'm Stephanie Butt, and I'm super excited to introduce Luc Wilson for us today. He is coming from New York City, where he works at KPF, an architecture design firm, but he also teaches at Columbia University. But fun fact, he's native to Albuquerque, and I thought that was a very important thing to point out, and that he was at UNM for a year, and that some of what he's talking about today I find is just extremely fascinating and a really unique approach to thinking about design, as coming at it from a data standpoint, and perhaps something a little bit unique than some of what we talk about here. But this stuff is not just reserved for awesome architects in New York City, but something that can find its place here as well. And without further ado, I'll let Luc take it away.
So I think before I dive into the heart of what I'm going to talk about with data, I'm going to talk a little bit about KPF, the architecture and urban design firm I work with. So I think that's important to understand the context within the data-driven work that I'm going to show you operates. It's a global design practice. We have 9 offices, and we really operate as one kind of big design studio, which is exciting to see design ideas translate from different offices and different contexts. And even though we're known for our super tall office buildings, really in the last 5 to 10 years, there's been a big pivot in terms of making great places and placemaking. And you'll see how data comes into that as well. And KPF has 3 kind of guiding tenets, and the first is the belief and power of urban architecture and cities, and really cities are the primary economic, social, sustainable drivers of the world. Belief in collaboration, kindness, and pragmatism, in how we work together, how we work with consultants and clients, how we engage with who we're designing for. And finally, and really important for what I'm going to talk about, is KPF is almost 50 years old, and how do we continue to grow and get better? And it's a focus on innovation, and a big part of that innovation is how design technology drives that forward at KPF. And so I manage design technology at KPF, which is 7 different teams. And so a lot of the office and leadership looks for us and these teams to drive innovation. And underpinning these teams are kind of 2 kind of foundational efforts that are go across all of them. One is what we call applied technology. That's looking into new hardware, software, workflows, and what's relevant, how we can adapt them. So for example, like AI, and I'll talk a little bit about that. And then where there's gaps in existing tools and workflows, we have a software development focus where we build out software plugins, web tools to meet that gap. And kind of moving into focus on data is really, and you're going to see a couple of themes here, but a lot of it is using data to de-risk decision making. I mean, ultimately, we're using it to make better places, but the more it facilitates consensus, and we do that through an iterative process of performance analysis tools, generating design scenarios. And core to that is building out custom analysis tools and figuring out how to measure what's important for the context we're working within, and a focus on visual representation and communicating what we do, where you see here, but even more importantly, and this is a theme of being able to deliver what seems as kind of the domain of experts into whatever tool or user interface kind of the end user stakeholder is engaging in. And so you'll see our web platform Scout here, which is a 3D interface for exploring designs with data, is sort of a reoccurring character because it's one of the things that helps bridge that gap. And even though this isn't going to be the focus, I wanted to kind of talk more holistically at the intro about design technology, is if what I showed you before is kind of working through the design, working towards goals, making decisions, but design technology also pushes that forward into the production of the buildings themselves and enabling us to really achieve complex and otherwise unachievable projects. So I've structured this into 5 sections around how I'm using data. First, going to talk about use of design through a couple of case studies, then in placemaking, decision-making, the development of a new master's program at Columbia, and then a little bit retrospective of how that helped shape the trajectory of my career. And so first with design, kind of two examples. And one of the things is we try to get these kind of pithy taglines that help really us understand what the value was. And in this case, this is a project in Tampa where we were the last architect hired within a large master plan, but ours was the first project delivered. And one of the big things is we were using kind of data-driven decision-making to facilitate that. So first we work with the client to first understand their goals and then back out how we'd measure those around a number of different environmental metrics focused mostly on daylighting, and then different types of views, and then building a computational design model. And in this case, it's a two residential slab buildings on top of a parking podium with a retail base. And so in this case, there was a question of what orientation worked best for the goals, and did stepping, the massing at all improve that. So we built this model that, as you can see, kind of rotate steps. It's broken out into the residential planning module, and it's snapping to the parking, the structure of the parking garage below. And so this is not, none of this is producing designs, but allowing us to quickly narrow down options and find a direction. So in this case, I told you Scout would be coming back. We built that out in the first week. And then in the second week, sat with the client and toggled through the different scenarios. And they're like, well, what if they're the tallest towers and there's no stepping? And then we look at the performance, and in what would have taken weeks of back and forth of generating one option, sitting with them asking questions, generating new, we're able to get through that very quickly. And that's an image of the built project. Moving over to California, and one of the biggest things we find, especially within the US, is how much parking drives our designs. And so in this case, we're using a similar set of tools, but focused on reconciling the parking constraints and rules with the other design goals and ambitions. So in this case, this version of that parametric model, we varied three different things. The first was the ratio of the residential wrapper in the wrapping the parking podium, how much was in that versus the towers, the tower location, and the tower form. And in this case, we tested over a little 2,000 options. And these, as I said before, not generating a design itself, but allowing us to test the viability of different approaches and make decisions. And a lot of this, when used in practice, maintains kind of optionality through the process. Because if something changes because of city regulations or the economy, we can go, well, maybe we should check this, go back to this other option. And so similarly, we built this out through Scout and had a number of kind of productive meetings narrowing down the design direction. And so it's both about building consensus, and I know the next, I talk about decision making and another one, but then also really relating form to performance and teasing out design insights, slab versus point tower, how does stepping really make an impact? And this helps inform how the design proceeds. So this is very early on in the process, but this is a rendering of one of the spaces. So next, how data is used for placemaking. So previously, where I showed two case studies, I'm more going to show like a kind of methodology we're working on. And the first part is about understanding programming and context. So first we look at what's there, what's missing from there, and then the experience. So what you see, how you feel, and where you go. And so we start, and we look at a number of kind of urban data sets depending on what's available, but one of them is sort of business and programming data that we can get from around a site to understand what's the distribution of different business types. In this case, we're looking at also the big diagram as popularity data for those different sites. But oftentimes that data is temporal, which is fantastic. So you can look at different times of day, days of the week. So this is an example on Friday where at 12 and 6, you see there's this north-south kind of commercial hotspot of activity with a little bit of an east-west. And then our site in particular becomes a dead zone. So that helps inform what the goals are and what the programming is. So that's looking at what's within the context. Next, we look at what's missing. And so in this case, we're using like a trip demand model from a lab out of Cornell, but essentially given an estimated population, their model backs out over the course of the week, what are the daily trips most people, or the weekly trips most people are going to take, going to work, grocery stores, outdoor activity, arts and culture. And with this, we can look at what's the population within the context, what is our program introducing, and identify if there's any surpluses or gaps. And so in the case of this example, the dashed line indicates the projected demand. So what we saw was there was a deficit across every single one of these kind of high level categories. And so we came back to the client and kind of say, hey, you're missing a real opportunity. But on the flip side, these are trips that if you're not accommodating within this neighborhood are going to become car trips outside of the neighborhood. So this is looking at how to kind of make this a more walkable city. Moving on to different types of experiential analysis, this somewhat drunk looking person wandering through an open air mall in Bangkok is we're quantifying what they see at every given point so we can understand programming locations, location different types of circulation. In other projects, we look at how far away are you from nature and trying to have increase the access to nature. And some of this, even though we're quantifying stuff, it's about kind of a qualitative experience. So here we're quantifying how open or sheltered a place is, not trying to maximize one or the other. But in this case, our metric was spatial variety. So trying to provide as many spatial options throughout the master plan. And this is one of the most important ones we've landed on now is measuring outdoor thermal comfort, because if a place isn't comfortable thermally, none of this matters. People are not going to want to hang out there. So we've really focused on that, especially the example we're looking at here is in Shenzhen, where it's hot and humid all year long. But what we've more recently done is we've combined outdoor thermal comfort analysis with a walkability analysis. So then as we model how people are likely to move through a space, which you're seeing here, looking at different simulated routing, we're now taking the outdoor thermal comfort into account in terms of people's decision-making and if they're willing to take a trip, but also more importantly, what route they're going to take, because they may take a different route depending on how, and that's important because sometimes we design these spaces and we render them as super active and lively spaces. But if you look at the comfort, people may just not be going there. And one thing I could do a whole different lecture on this, but I think a big thing that we try to do is also check our own bias in the models and simulation we do, because I'm talking a lot about performance and meeting these goals, but it's comes down to who is it for. So oftentimes we make that not us. And so in this example, it's thinking about a similar origin destination routing simulation, which in this case, I think we were assuming, an able-bodied person walking at that speed. But in this case, how do we design for a demographic that can't do stairs and can only do the elevators? Are they located conveniently, similarly going at slower space? So for all these tools, we're trying to back out who are we designing them for and making sure our own bias doesn't get into the algorithms. And this is one of the spaces from this plan. You can see it's a multi-level plan, so convenient accessibility was a big part of the design. I mean, everything I've been showing is how data is used for decision making. It's really underpinning everything there. This is going to focus into a subset on it, which is maybe more about stakeholder engagement and consensus building around decision making. So this is actually putting two projects together, but it's about converting NIMBYs into YIMBYs. And if you're not familiar with NIMBYs, that's not in my backyard, where you don't want a new development or a new transit project. And so these two are about yes in my backyard. And they're both kind of going through kind of bottom-up education to help with decision making. So the first one is a project we did with Google for a master plan they were doing in Toronto, which has died now and hasn't manifested. But one of the things we did is we created an abstracted version of their master plan and generated different combinations of density, open space, building type, and measured outdoor thermal comfort, energy generation, and views, and worked with an interaction design firm to design what you're seeing here, where someone can interactively toggle the different elements and see the output. And one of the interesting things that happened is at the opening day for this, there was one woman who was here for close to 30 minutes, and I went over and kind of asked her, oh, what's going on here? And she explained how the tool worked. And she said the first thing she did was the least amount of density, the most amount of green space, because she wanted green space, she wanted her own backyard, but then she saw it didn't perform well for outdoor thermal comfort and energy generation. It's like, well, those are two things that I care about. And so she spent all that time toggling the options until she got to one that performed well, that she also would want to live in. And she said, in the end, I realized I care more about those two things than I care about really having my own backyard. And that's kind of my dream for the use of this sort of accessible data, is for stakeholders to come to their own conclusions in a bottom-up way, rather than, I'm an expert, I tested thousands of options, here's what we should do. A related project is one we did for the Hawaii Public Housing Authority and the University of Hawaii, where similarly we generated a kind of a parametric neighborhood model. In this case, it was based on different Hawaii neighborhood typologies and looking at different density configurations. And this was, the Hawaii Public Housing Authority had 2 new transit stops they were looking to do development around, and they wanted to do mixed use and at a higher density than was common except out of like Honolulu. And so they're working with the University of Hawaii and then us on an education campaign, but also to solicit feedback. So understanding the benefits, which have to do with walkability and outdoor thermal comfort, what did they want to see? So there's some screenshots from the web app we developed for that. And then it was part of an engagement campaign that the University of Hawaii ran. And so similarly, it's trying to present people with kind of different options of the built form, performance, and allow them to come to their own conclusions and give input. In a more speculative project, but along those same lines, we also worked with the online publication platform Quartz, who I may or not be familiar with, but they were having a whole series on climate change, and we worked with them to imagine a fictitious climate haven in the year 2057 called Leaside. And the whole premise was climate change has gotten to the point where we're going to have climate migrants who are leaving like coastal cities, for example, where climate change has made them inhabitable, and other cities that are more climate resilient. In this case, we were kind of Rust Belt around the Great Lakes would be climate havens. And so we designed this fictional city and then imagined it out to the year 2057 with a scenario that you are a city councilor and you've received funding from the federal government to accommodate climate migrants, and to use this as a digital twin planning tool to how you allocate space. And in this case, we were looking at housing, energy, public space, but you were seeing what percentage of the target population you're housing, but then also, was there enough space for employment and jobs? How much public space did you have? What was the total energy generated relative to the demand? And so this was a useful kind of speculative engagement case. And back in 2022, Scout, which is the underlying platform that we built that you've been seeing here, it won a Fast Company Award for data design. And these are the runner-ups. And I'm not putting that up there just to brag, but I think what this shows is these are more prominent groups and organizations. They're larger, they have more resources, but that, at least I'll say the judges, but general public is so interested in engaging within the elements of design and city building and planning in a way that's accessible and intuitive, that we won over these other groups. And so for me, that was an aha moment of pairing design thinking with digital tools can be so much more powerful than like a large technology company. And so moving on to what I do outside of KPF in terms of teaching how data is used for a new master's program is a couple of years ago working with a professor at Columbia. She assembled kind of a group of 5 of us to help create the curriculum for and to develop a new master's program, Computational Design Practices. It's only its 2nd year, so the first cohort just graduated, and I'll show you some of their work. And the whole premise for that was, over the past 10 years, there'd been a number of graduates out of the architecture program who are getting into kind of spatial technology, working with data, computational design, and in different career trajectories, but linked by that common theme. I grabbed some kind of images of those types of work. And the whole premise of the program is, how do we create a program that kind of structurally creates those types of graduates that were happening somewhat by happenstance within the architecture program, sort of not consistently. And so the program we designed has 3 sections: a colloquium, which is kind of their version of a design studio, but they're not doing a design project. A major difference is there's kind of each one relates to each other. So you start exploratory, you design a project, and then you kind of create a real proposal in the last semester. There's foundational courses. And then one of the things that we were leveraging on is the architecture, design, planning program, preservation at Columbia has dozens and dozens of really great electives. And so it was really taking advantage of those. But one of the challenges we had is we were looking to attract students from different types of backgrounds. So we couldn't assume they had any design or architecture. We couldn't assume they had any computer programming. And so we created this foundational course, which is fully online, which covers a whole range of topics. And so before they start the in-person class, every student goes through this with a kind of a custom assigned curriculum. And I wanted to kind of point out that this is all free and available online. So if you Google GSAPP smorgasbord, you'll find it, and has a bunch of standalone mini courses across a range of topics. If you're new to Rhino, you want to get into Grasshopper, you want to learn Python, mapping in GIS, web development. And one of the interesting things about the program that's merged in the 2nd year a little bit more tangibly, and you can see that the foundational courses is the one I teach, computational modeling, is really computational design, my flavor of computational design modeling in Rhino and Grasshopper. That's paired with a web development course, and that's paired with mapping in GIS. And so the 3 projects I picked out, these are capstone projects, show how those are integrated. So this is a web mapping tool that the student created, where she took every single open space, vacant land, and parking lot in New York City and created a weighting system for evaluating its viability for urban farming. And so some of it had to do with proximities, like proximity to food insecure neighborhoods or highways, which makes kind of delivery and transport more really accessible. But one of the interesting parts is she also analyzed every single one of these spaces for direct daylight during the growing season. And so it's bringing together kind of unique spatial analysis that you can do on the design and architecture side with mapping and into a web platform. Or another project, kind of completely different, but you'll see kind of these are all kind of spatial and computational a certain way. This is, student did almost a kind of a data-driven journalism project, getting into the changing produce network in Chinatown in New York, and both doing interviews, looking at past studies, and kind of mapping the changing framework. And in fact, this was picked up and became an article in the Washington Post, which was great. And then the last project I'll show from this program is someone who made like an alternative to Google Street View. And so it's an app where you can go take a picture of your space, you upload it to a web map, it geolocates it, but then what they're doing is automatically running an image segmentation analysis to classify the different materials within it, whether it's sky, vegetation, brick, and you're seeing that sort of word cloud there. And the idea behind this was, for spaces you like and don't like, you can go take images of the space, of what you like and don't like, and then refer back to the analysis and understand the composition of these, and you might see certain trends you didn't realize otherwise. Finally, a little bit about how data shaped my career and got me to this point, since I thought I might be interested for the students to see kind of where I started and where I got is there was a lot in my education, but in particular, there was this project, Lower Manhattan, or LOLO. This was part of a team, and we were speculating about using material that's dredged out of the harbor of New York daily to maintain shipping channels to extend Manhattan and create a new neighborhood. But we were also working with real estate development students, and one of the things that we did was connect their performa into our urban computational design modeling, and allowed us to test out different design and development scenarios and relate that back to what was the overall, what could we do with this as a large infrastructure project. And coming out of that, I was a little bit after graduation, was able to pitch that as a concept to KPF to come on and do that type of work in the context of the work they were doing, which was the kind of the design modeling paired with analysis and metrics. And at that time, we're pitching it as X information modeling, or Zin, or play off of BIM, where you can sub in the sort of different things that you're looking at kind of measuring or modeling, from zoning to building information to sustainability, and a little bit of a timeline. I think there's some interesting insights. I'll show a little bit kind of early on. The first tools we built were around view analysis and automating zoning analysis. And the real traction and agency came when presenting those to a few clients, and then suddenly every client was requesting those. And that changed the whole expectation of how the office was working, and then relative to what our competitors were doing. And then a little bit later, launching into KPF Urban Interface, which was taking on more of an urban focus and establishing more as kind of urban design subject matter experts. Moving into the work I showed you with Sidewalk Labs, where we're really working out how to work at the urban scale and starting to do software development. And then in 2020, you mentioned kind of that shift of focusing on placemaking and doing more serious software development, treating it more like, we were a small technology company. And then more recently, more broadly across KPF, how do we leverage 40, now almost 50 years of experience? How do we get these tools working? And so kind of to show early on, this were some of the very early analysis tools that we were making. One of the big things was, these are kind of snapshots of 2 complex New York City zoning code regulations. And kind of a naive new graduate, I was reading through the zoning text for a project I was working on. I was like, this is a set of rules. I can do this. And then building out parametric versions of it, only to learn, especially the kind of dancing party building on the left, that analysis, which is a type of spherical projection, so you're doing a lot of trig manually to map it onto different graphs, takes someone who knows how to do it about a day to do. So after doing this and using it on a particular project, the Department of City Planning actually reached out to us to have us help them on a series of rezonings where they needed to revise this particular regulation, but did not have the ability to test scenarios fast enough to actually do that. So I mentioned moving into figuring out how to do kind of parametric urban design, or kind of computational design modeling at the urban scale, was a real breakthrough. In this case, it was kind of procedural generation linked to street center lines, and you'll see a little bit more of this later. And then finally, the work with Sidewalk Labs, where that all really came together. And so in conclusion, kind of I had data, it was the data heart, but really it's data plus a real subject matter expertise. Like with the example with Scout winning that award, it wasn't the technology or data itself, it was pairing it with the kind of spatial thinking. So these different examples with zoning or placemaking, it's really like my ability as an architect to think spatially and combine it with the data and technology. But I know AI is a hot topic. So now we're in the post-credit scene. And so this is we only have one post-credit scene, but it's about AI. And one reason why I didn't make this topic, the lecture all about AI, is that one, it's really new. There isn't really enough interesting for a full lecture. Two, it hasn't yet influenced design in the way that the data that I was showing. So it was less interesting from a design standpoint, but it's so fundamentally shifting how we work, if not our designs, that I thought it'd be useful to talk a little bit. It has a much different timeline than the one that I showed you, where in 2013, we first started with a data science focus and looking at machine learning, kind of dabbling. I'll show you a little bit of that, what worked, and then all of a sudden in 2023 with generative AI just exploding and realizing we have to treat the tools that are coming out of this as foundational tools to our practice in the same way we treat Rhino or Revit or the Adobe products. And really where we're going now, we've scaled up these tools across the entire office. We're looking at custom generative AI. So, back to 2013, some of the things that we're doing with machine learning that were providing fruitful. One was using it to train machine learning models for real-time simulation prediction. So this is for CFD, which is wind simulation, which is really computationally heavy. It can take 8 hours for a single option to test and run. So speeding up complex simulation. More recently, we've been using it to kind of leverage that almost 50 years of design. And in this case, we're using machine learning to create a floor plan and core recommendation tool. And so there's two different types of machine learning here. At the top one, we're doing image segmentation because the biggest struggle is taking what you have and getting it in a structure that then you can actually leverage machine learning or AI. So the first one is just training it to identify what's a core, what's an elevator, what's a stair, what's the outline of your building. And then once we have that, we're pairing it with metadata that we already have with each project, where it's located, what's the program, how much GFA, what climate is in. And now we're then using that to then use another machine learning model, a similarity search, to make this recommendation engine. And so this is meant for junior designers. They're starting off on a project. They can't wait a day or two to find the planning expert. They can start here, enter the elements of their project, and get the 3 most similar KPF projects, for example. And one of the reasons we started off, and at first we were going to automatically generate the office core for them, given the inputs. There's a describable set of rules that we can take and generate that. And we ended up going with this kind of recommendation engine for a couple of reasons. One is we worried then junior designers wouldn't actually learn how to design cores and kind of plan these different program types. So we wanted to give them more of a teaching tool. You can see related projects. The tool does tell you how many elevators you need, and it's up to you to design them. And we worried also that the output of something like that, while maybe getting you 80% of the way there, would look too close to a finished core and a plan, that it might make it through to a client and cause issues. And I mentioned software development. I haven't really focused on that too much, but a big push is taking all of these things that we're doing from data analysis and generation to custom AI models and deploying them within tools and platform that everyone can use. So what I showed in terms of that core recommendation engine exists both as a web tool we've developed, if that's where you're comfortable using, and both as a Rhino plugin, so as you're modeling, getting real-time feedback. Moving forward to generative AI, and unfortunately I can't show too much because it's so new, it's all on new projects that we can't talk about. But on the image side, there's a couple of things we're doing. A big one is I call it custom precedent generation. So what you're seeing here is all generated with Midjourney. And this is the start of a project to test out kind of different design approaches, not from kind of a massing standpoint, but from a style and materiality standpoint. Test it out, what is kind of resonating with the client, what are they thinking? And then next that you're seeing from that, we can also use Midjourney to back out the material palette. And then once we have that, then we can start in on the design. So it's really kind of decision-making and efficiency. Similarly, while these look like designs, in no way do we present them or think of them as designs, but this is for a master plan where we were testing out different approaches to different spaces to see what the client and then the city were interested in pursuing, and then we really got started on designing. Another application is kind of instant renderings, and unfortunately, I can't show you the best examples of here where you're taking essentially a screenshot from your Rhino model and turning that into a rendering with just a few adjustments, but saving a ton of time. And so in this case, you can see the original rendering, which is not that bad, but instantly turning it into an improved rendering that's more stylized. And so I think professional renderers have more to worry about, at least now AI is changing so fast, than we do as architects. And similarly, using AI to stylize images, because oftentimes we haven't taken a design far enough where we don't have enough details worked out that we want to show something that's a realistic rendering. Or maybe just kind of what will resonate with the client, how we want to represent it. And so we've been experimenting with these kind of instant stylized visualizations and kind of leaning into kind of a watercolor representation that works really well. On the text-based side, so we're using kind of different large language models. In this case, it's ChatGPT. And one example that was really interesting at the top, you can see we've already done some data analysis on a couple of neighborhoods. We've narrowed it down to kind of what we've processed, but we were struggling in terms of getting insights out of it. So we uploaded it to ChatGPT, asked it a couple of questions, and at the end, you can see here, based on the unique characteristics of each district, derived from the mean building area and the most common land use, can you, oh yeah, that's what they said. But yeah, so we were having it describe things because it's really good at patterns and trends. But more specifically, we're developing kind of narrowly focused large language models. So ChatGPT is a large language model. And we're doing narrow ones where we have something very specific. In this case, I'm showing a lead bot, so asking questions about the lead sustainability certification, but pulling from our own internal database for that. Or we're doing another one focused on just being able to ask questions about 20 years of KPF proposals. Like, what was the last project we did a library on in North America? And through the early explorations of machine learning going back to 2013, one of the things that we were first excited about when we're generating these urban scale models with hundreds or thousands of design options, each one of them has a dozen or more features associated with it in terms of performance metrics and configurations. We were like, this is perfect for machine learning. We can train a model that's going to very quickly get us insights that we're not getting out of this. And after a while, we're like, it was taking us a really long time to get anything meaningful. And all of the insights were really obvious, like ones that we'd gotten instantly from looking at the results. So instead, that's when we pivoted into Scout, which I've shown a lot, is one thing that we realized is that a human, and especially designers, are much better at making those inferences when they see the model and when they see the data. And so, for example, in this case, if you filter down to a bunch of options that perform really well for view, you as a human can look and see, oh, I see, it's because there's a bunch of small parts which are then staggering the towers, and the towers are looking past each other, and that's what's working well, where we could not train a computer to do that. So instead, we pivoted into this more kind of maybe augmented intelligence is a way it's been described. So more tools that work with us in the design process. That's kind of one thing that came out of the kind of early failed attempts at bringing machine learning and AI more into the design process. The other one was then focusing on procedural modeling instead of AI to automatically generate things. So embedding our own intelligence. In this case, these are street center lines where we're procedurally generating street types that we've designed with our expertise. And then, populating with building types. And so I think when it comes to kind of AI, so far the question about it and design was over very quickly. There was like, for a month, that was all anyone could talk to. We can't be using for this design. What do clients think? Very quickly into the case studies that I showed in terms of helping with decision-making, efficiency, and what we're doing. And then things that we thought AI would be doing, like getting design insights or automatically generating, it's more methods where we're either creating tools that augment our process or embed our own intelligence into the tools themselves. Thanks.
Well, thank you so much. That was absolutely fascinating and delightful. Open up for any questions from the audience. Yes, Adam.
What was the name of that? What did you show us? It's like,
That had the online courses.
yeah.
It's called the Smorgasbord. And so if you Google GSAPP, GSAPP Smorgasbord, it'll take you right to it.
And how do you envision maybe students here making use of that? Could you give one or two examples of how you could see them maybe coming there and finding something useful?
I mean, you described how you do it. I think you can go there. Each one has a little preamble about what you get out of it and showing the type of thing. And so it's very clear in their kind of standalone courses. And so in particular, the topics I talked about, modeling in Rhino, computational design modeling in Grasshopper, mapping in GIS, Python, both for kind of Python within Grasshopper and Rhino, and Python for data analysis and mapping, and then web development are the different courses.
The problem, how does KPF build these services? How do you build the research into the overhead? What percentage of the overhead goes into research and development to produce outputs?
So the sort of
KPF is for profit.
yeah.
It isn't, but
Yeah, and one of the interesting things, because it took me a while to figure out why our model felt different, because oftentimes I had people trying to do similar things at other companies, and they're like, how do I justify this to the leadership in terms of overhead? And one of the things I started on early with what we were doing, being presented to clients and clients asking it, because the value was seeing so directly in terms of winning new projects, facilitating early design decision makings, there's never been a question about the overhead of this. And in fact, across design technology, maybe 60 to 70% of the time is built to projects. So the actual literal overhead is very little, but there's never been a question about like, ooh, this is too much overhead. And I think it's that kind of being part of business development and winning projects from the start really made the difference.
so the software that you develop proprietary, I presume so. You sell services to other firms?
We don't. We've thought about spinning it out, and even with Scout, making it open source, because for us, it as a web platform, its value isn't that it's a 3D web platform. Its value is the models and data and design we put into it. And the big reason why we haven't done any is, one, to kind of commercialize anything. We don't think there's a big enough market relative to the amount of effort it would take us to support a commercial product. And on the thought of open sourcing it, is talking with other people who've done open source projects. You actually have to invest a lot of your own time to make a community around the open source project to make it successful. And we didn't think there was like time or effort to do.
No, I was talking about selling services.
So both, yeah. But we also, like, as I mentioned on the business development side, the value is so strong there that like another architecture firm hiring us to work as a consultant for them doesn't make any sense.
Well, let me ask a related question. You're a big firm with, high value projects, and you can afford to do this. But what about, smaller scale practitioners? What about cities providing useful data sets, providing software, analyzing their own zoning, not really knowing what they want, and supporting, kind of smaller scale firms and smaller scale projects that could use this kind of methodology. They could access the methodology.
So I guess there's two questions in there with like smaller design firms and practitioners. I think that gets back to my previous answer, where it's about using data and specifically spatial data, which we're good at generating, in a way that helps facilitate decision making with a client, because that speeds along a project, or through showing that your tools can increase the performance of a project and helps you win that project. Then that it's not really a question about kind of investment. It becomes core to how people work. On the city side, yeah, I don't really know. You could do something similar tools in a city, because I didn't really show anything here that's actually leveraging data produced by cities. That could be a whole different lecture.
Thanks for the presentation. This is probably more of an academic curricular question. This is a new toolkit, for designers, and I wouldn't say new, it's relatively old now. But I think, academia is still struggling where we introduce data, in the curriculum, and how important is it, for future students to be able to harness this technology for the future.
If you'd asked me, like, even just 4 years ago, I would say every architecture student should learn some coding, should learn Grasshopper, and I've sort of shifted a little bit. I think a subset who resonate with that should focus on and do it, and more broadly, a willingness to engage with new tools, because creating the interfaces that I showed, like, a web interface, is becoming more and more accessible and easier. That can be specialists who are doing that, but your ability to be like, sure, give me this new web tool, I'm just going to start using it, or this Rhino plugin. In terms of like how to introduce, like, let's say Grasshopper and computational design modeling, what did the trick for me, even though I was using it kind of from my first studio, was a studio that said we're only designing in a parametric design software. And it forced me to reset how I was thinking in a productive way, because otherwise it was sort of in two different camps, and I wasn't really able to think about how to leverage these tools properly.
Curious, regarding security and policies and chats, GPT. Does your company have policies regarding putting that in front of the classified information that you uploaded or asked questions about?
Yep, that is so much in my past 6 months in a very boring way. But it's like only doing like whatever the pro version is, that in the terms of service say your data is classified, it's not being used to train the model. And then when we do luckily KPF is in a position that we can afford to pay for those additional licenses rather than just the free services. Because it is a huge issue if an image from a classified project somehow gets there, that could lose us the project. And then at least for the kind of internal AI, since we're putting them up on kind of Amazon Web Services that we control, servers ourselves that we control, we know it's all private, but it's a huge question, and one that's really taxing leadership's ability to engage with something moving so fast. Because I've gotten the answer, well, you tell me this is safe, but it's on their servers, they can just do whatever they want with it. It's like, well, the terms of service our contract with them doesn't say that.
Thank you for the I wonder if this design component is missing in this design process, or any challenging to compute or keeping. For example, I think use digital design kind of cool, but when we interpret design architecture with this computer technology, I think we can create a building there. It's the identity flags here. Is it like any component you would be challenging for you to compute?
Yeah, I mean, because the biggest thing is recognizing we can't fit everything into the digital models. And so rather than trying to use this as like a comprehensive, these methods as a comprehensive design tool, it's using it to answer and address very specific challenges, constraints, goals, and recognizing that the output isn't a design, but helping us focus the design direction that doesn't take any of the design agency away. So that's been a big one of like, these have a whole set of limitations. These are very narrow applications. They work well, and they're not designs, but the start of design. And so that's been.
Yeah, how is the software and the use of it, even for the exposure that you use it, how does it change your relationship with the client? And how do you, I don't know, does it change like the fee structure, or does it change like the early discussions, or even I don't know, how you just begin conversations about those things?
Yeah, so at least the kind of data-driven testing options, like, hasn't changed how we bill our projects or our fee structure, because the benefit in terms of either winning the project or speeding along the early decision making, like, was enough value that we didn't have to try to explain to a client, we're going to charge you X more because of this thing. But on the flip side, for some of the more in-depth stuff, where it is like more of a like software that we are developing for a client, say, we will have a separate fee and do something differently. And for example, until kind of a year ago, the tech companies kind of went into economic crisis. We had a separate scope and fee with Google to develop kind of an interactive web map digital twin for the master planning of projects in San Jose. And so that had like a separate kind of fee that was independent. So we're sort of like, I mean, a long way is maybe to say balancing the benefit in terms of winning and facilitating projects versus what we can actually charge for independently of those.
What's your editing process? Was this the design based on like when you see models that works really well in so many aspects, how is putting it like this, like what is the editing process?
So my answer is not going to be very helpful to you, because with this workflow and what we're doing, we're not the ones then actually doing the design and developing it. There is no process. And that's different for you, because if you're leveraging those tools, then you are moving that into the design process. I mean, I guess the main thing would be to be aware of the limitations and what is not in the model and what you're not addressing. And then to address those things, that's then where you take the output and start to refine and customizing it. But maybe these tools help you land on an overall massing strategy and citing that then you refine through the other considerations that are not included in a methodology like this.
That's great. Unless if there's one last lingering question, these have been amazing questions. But if, what last one? Yeah.
I have a question. I'm trying to still articulate it, but I very much appreciate that you recognize the big sort of data, or the data as a tool, that it doesn't just create the design. It is about creating knowledge to inform the design. That world is fascinating to me. It's also kind of terrifying because I don't quite understand it. And my biggest kind of concern, as a sort of an educator and a lover of being like outside, is the kind of knowledge one gets from living outside the computer in the real world, and that sort of like embodied knowledge of being in a landscape and sitting in a building. And I think maybe what Francine was getting at, like, you have a certain data set that can create certain outcomes, but there must be so many subtle variables about being in touch with the living world that can't be turned into a data set. I don't know, you have, I mean, you think about those sort of questions too, about that sort of world of coding and inside versus like being outside and not like, I mean, I certainly totally simplified, but you know,
Yeah, and
we're
I,
dependent on Google for answers or plugging something in for answers as opposed to being a living being in the world and observing.
and so not that we can do that for everything, but one of the things when we're like building, like, because we have a lot of the experiential tools that are kind of qualitatively driven, like open or closed, is that we'll kind of build them and then go walk a bunch of spaces and kind of record our qualitative experience and then look back at what it was kind of giving us. That has like its own limitations because it comes with our own bias of like, I experience a space in one way. If I were doing that in kind of an academic context, I'd probably set up kind of surveys to get more of an aggregated, and a big thing is trying to take some observation about the quality and experience of a space, figure out some proxy, it's not one-to-one, of measuring some aspect of the space that might reveal something, whether it's the amount of vegetation, how much kind of transparent versus opaque surfaces there are, modeling where people are going and seeing if there's some sort of insight that then would help in designing future spaces that would achieve that quality. It's sort of nebulous, but that's how we're kind of addressing that.
Yeah, I think we're right in perception, I mean, every space. People have different experiences, like gender and beach and all sorts of, you know, variables. Yeah.
Yeah, and it's impossible to do them all, so kind of check our own bias in the process and understand the limitations and use it what it's good, like what we, within that context, what we think it's good for.
I thought that was a great question to kind of end on and keep, it was fascinating talk. But can we give us another round of applause for? And thank you all for joining us this evening.